Hey guys, we are back with the Godot 4 video course part 7. In this video, I would like to focus on the explosions and similar visual effects. After all, we are creating a space shooter, so players would expect to see a lot of destruction, fires, explosions, just everything that belongs to an arcade game. Let's explore the capabilities of Godot. We begin with introducing a fire explosion that emanates from the asteroid utilizing a spatial shader. The code of the shader is not entirely my own creation. I discovered a similar shader online and made necessary modifications to make it compatible with Godot 4. So let's briefly discuss the fundamental logic behind this effect. Let's start with creating a new scene. There it is. Create a new scene and we'll call it, we'll make it node 3D and call it explosion. Okay. We'll save it and attach a new script, explosion GD. Now we need to prepare a new top level folder which will be called shaders. And let's find the folder, right click, create new resource, and the type of resource will be shader. Okay, and we'll call it explosion GD shader. Let's double click it and the code of the shader opened here at the bottom part of the editor. Now I have the code for the shader prepared in the text editor because it would take too much time to type it manually line by line. So let me just open it here and select all, copy and paste into this. There it goes. Now we will add a child node to the root node of our explosion scene, and we need the type mesh instance 3D. Let's rename it to fire. The node is selected in the inspector and we click mesh, yes, and select new quad mesh and click it again. Now we need to add a material, and this time we'll be creating a shader material because it will be driven by this code as a procedural material. Let's click it again and we will drag the explosion to the shader property. Okay, looks like it works. Let me get back quickly to the shader code. You may have observed several variables in the shader code. Prefix it with uniform. This is basically the same like the annotation export we'll be using in our scripts in Godot, so it allows us to edit these properties here as shader parameters. Among the variable, there is also one specific one called instance uniform. This distinction implies that this specific property can possess a distinct value in each instance of the explosion effect. Conversely, the remaining variables are shared across all instances. It is very important as we aim to display multiple explosions simultaneously on the screen, and we don't want them to be all synchronized and showing the absolutely very same effect. So now, with the explosion effect in place, next step is to gain control over it through code. The control will enable us to manipulate the fire's expansion and contraction according to our desired behavior, so it would really look like an explosion. Let's open the script explosion GD, it is here, and insert new code into it. So this time we will keep the function ready because we want to actually set up something here. Let's drag the property, the node fire is control, and we create several more variables. Fire width, fire height, fire var fire speed, and var fire aperture, which is set to 0. Okay, let's fill the ready function. In this function, which is called just when the node is ready to be displayed in the scene, we need to detect we need to set the size of the fire mesh according to preset variables fire width and fire height. So we will do it as a vector 2 with these variables: fire width, fire height. Okay, that's all in this function. Yes, it seems Godot doesn't like it for some reason, because we are using fire mesh, and this is fire mesh, of course. Okay, now it is okay. Let's create our usual function of init x, z, width, height, and speed, which defaults to 1.0, and there should be equals. Okay, and colon. We need to position the fire to these coordinates: vector 3, x, 0, z. Again, the fire is displayed at the exact plane as well, so the y coordinates is always 0. And let's set the variables. Fire width is width, fire height, and fire speed is speed. Okay. That should be enough for the initialization. Now we need to process the fire to make it animated. So let's do this. If fire aperture is less than 1, fire aperture increased by delta multiplied by fire speed. Okay, and we want to pass the parameter to the shader code, which will be done here. Fire mesh set instance shader parameter. That's the one we marked as instance uniform, and the name is fire aperture, and the value is this. Very well. And once the fire aperture reaches 0, we would define this else branch, and means that the explosion effect can be released. Okay, that's it. So we have explosion, but of course it would be great to have a sound of explosion to play some boom effect when the asteroid or another object is destroyed. And again, I downloaded the sound from freesound.org. It's already ready here. Let me just import it. And again, we have to make sure that the sound is not looped, so the loop mode will be changed to disabled and re-import. Good. Now we need to add a new audio stream player node to the sound manager. Let's open this scene. Right click, add child node, audio stream player, and we'll call it explosion sound. And let's drag this sound file here to the stream property. And of course we need to amend the code, so let's drag with control this node to the code, and let's create a function func explode explosion sound play. Great. And we need to use the explosion scene in the game manager, of course, because that's where the logic after the object is destroyed resides. So let's save everything and click to game manager. We will add a new function, create explosion. First, we need to add the explosion scene here. Where are the scenes? Here. Explosion tscn, control, and again already var explosion scene. Okay. We will add a function here. Create explosion. Add the root node, of course. Now we need source node to know which enemy instance should be destroyed, and the parameters of the explosion, because some enemy ships would create small fire, some kind of boss enemies would show a much bigger fire. So that's what we'll define by these last two parameters. And let's implement the function. So var explosion is explosion scene instantiate. By the way, I think that this is one of functions, instantiate, that was changed from Godot 3 to Godot 4. It was something else in Godot 3, so that's why it's important to work in Godot 4 following this tutorial, otherwise the script wouldn't work. Var speed is 1.0 and explosion init. And let's pass the parameters. Source node, global transform, origin x. This is the x coordinate of the enemy object being destroyed. The same will do for the z coordinate. Let's copy paste z. Let's make it better formatted like this. And what do we need now? Yeah, width, height, and speed, of course. Width, height, and speed. Okay, that should be enough for the initialization. Now we need to add it as a child node as usual. Root node add child explosion and play the sound. Something is exploding. Sound manager explode. Okay, and finally we need to get rid of the object that exploded and should be destroyed. Q3. Okay, and of course we need to modify the callback function in the main script. where it is here. So instead of enemy Q3, which already moved to the create explosion function, we will just call this create explosion function. There it is, with parameters self, the root node, enemy, the source node, and let's say 15 by 15, the dimensions of the fire. Okay, let's execute the project and see what happens when we destroy an asteroid. Ah, exploding, right. Perfect. Ah, we got destroyed, of course. Very well. As for the shader code, if you want to examine it in details, just feel free to navigate to GitHub and to the project which is associated with this course, and the whole source code is there. So I believe it's not necessary to go through it line by line in this video. Okay, let's go on. We have an explosion, which is great, but there is one small problem with it. The explosion is displayed only after the enemy is fully destroyed, which typically requires multiple hits. It would be amazing if we can introduce an additional effect for other cases, like the enemy is only hit but not destroyed yet. So let's try this. When a bullet hits the enemy, it will emit a multitude of rapidly moving sparks, like the enemy is only damaged and something is flying away from that. This scenario appears to be a typical application of particle systems. In Godot, we can use two types, GPU particles 3D and CPU particles 3D. For this specific case, I selected CPU particles 3D because I remember that when I've been working on my own game several months ago, there was some issue with GPU particles 3D causing some annoying visual artifacts on Windows 11. I think that there was no solution available during that time, so I just worked on the workaround and rewrote GPU particles to CPU particles. Right now, as we already have Godot engine 4.1.1, the issue was fixed and everything works perfectly. But I think that we can still stick with CPU particles 3D for this effect, as you just learn something new and the visual difference is minimal. Let's create a new scene in the scenes folder. Right click, create new scene, and we'll call it hit effect. Okay, and we'll rename, change its type to CPU particles 3D. Save it. Okay, to achieve the effect we want, the setup of particles involves multiple steps. Let me just guide you through them. So we click the root node, open it in the inspector, and set the following properties. Emitting on, which is okay. Well, let's open the 3D editor to see the result. Amount, we don't want only 8 particles because that's just not enough for the effect to be visible. Let's make it 100. Okay, now time, lifetime. 1 second is too long. We'll make it only 0.3. Okay, now drawing, there it is. So we'll work in local coordinations, and the mesh will be set to new quad mesh. It's already something here visible, and direction, we want to spread it in 180 degrees. Okay, let's proceed with gravity. There should be no gravity here, so we'll set it to 0. As you can see, the particles are no longer dropping, which is correct. Now the initial velocity should be 3. Okay, something is happening. And the maximum velocity was set to 3 as well. Now the angular velocity, to give it some twist, let's set it to 1. And scale, because we don't want all the particles to be the same size and definitely not that big. So we will set the minimal amount to 0.05 and the maximum amount to 0.1. Now it looks more like sparks, doesn't it? And we want to give it a better color, of course. So let's make it as an initial ramp, as a gradient. So the color is various, not always the same. Let's click it and do something similar to this. This gradient editor is not too intuitive, so I might won't be able to do exactly what I intended, but I think it's not a big problem. Let's do it somehow orange and move this a little bit here. Okay, let's suppose this is the correct gradient of the effect. Now we need to do something about the material. Let's get back to the mesh property and click it, and we will assign new standard material 3D. Click it again, and we need to set some parameters here. First, shading. Shading mode should be unshaded because we don't need this kind of features and we just save some CPU time. Now vertex color uses albedo and we should already see our gradient. What else? Albedo color. Let's see if it's necessary to do something about that. I'll try to set it to the similar orange color we had there. Yeah, it seems to be coloring that a little bit, which is good. And now what else? We need the billboard mode, so the particles would be always facing the camera. Where is it? Albedo. Billboard here, billboard mode. Let's give it to particle billboard. And of course, we need to do something about the scale. Keep scale on. There it is. Okay. Okay, now we set the individual lifetime of a particle to 0.3 seconds, but considering that we emit a minimum of 100 particles for each instance of this effect, and there will be multiple instances as we probably will be hitting multiple enemies, it would be good to impose a total lifetime limit as well, for example, half a second. To accomplish that, we will include the necessary script modifications along with other relevant adjustments. Let's attach a new script, hit effect GD, and insert this code. So it extends CPU particles 3D, which is correct. We need a variable elapsed time to measure the lifetime, the total lifetime. And now we don't need this. And we will create the init function. Coordinates of the particle effect. Okay, what is this? We usually use 10 as a y coordinate, but now we have, we usually use 0 as the y coordinate. Now we have 10. Why is that? Well, it's simple. We want the particle effects to be always visible. So they should overlap the enemy ship or asteroid model a little bit. That's why we position it closer to the camera, so it would never be obscured. Now, emitting, which is a parameter of the particle of the CPU particle 3D object, set to true, just to be sure, and restart. Actually, these two lines, this is a workaround. It was there before Godot 4.1.1 introduced the fix regarding the visual artifacts there, but I think we can keep it there. it's not necessary to use them or remove them, your choice. What we need now is to process the particles, so we increase elapsed time by delta, and if elapsed time is greater than half a second, let's stop emitting and get rid of it. Okay, good. And of course we would like to add some sound effects to this particle effect. So let's find the folder sounds, and I already downloaded again from freesound.org 2 sounds, rock hit and metal hit, because we will play different sounds when the bullet hits an asteroid or a metal ship. So again, let's make sure that the sounds are not looped. I think this can be set globally as well, but I don't think it's necessary to do it right now. Okay, and again, let's open the sound manager, create a new child nodes audio stream player, which would be metal hit sound, and one more rock hit sound. Let's drag the right sound files there, metal and rock, and we'll create another 2 functions. Okay, and the second one. Okay, good. Now we need to create a new function in Game Manager to implement this effect actually. So again, we will drag the new scene as a new variable with control. Already var hit effect scene, and let's scroll down and create a function, create hit effect. Add the root node, of course, and we need to know what we hit, what kind of enemy, and where exactly the hit happened. That will be the coordinates of the particular bullet. So let's instantiate the scene. And initialize that with the bullet position X, bullet position Z. Don't forget to add this new instance as a child node. Hit effect. Okay, and now we just want to distinguish between metal and rock enemies. This will be done later as a new group of these particular enemies. Right now, let's suppose that if enemy is in group metal, let's play the metal hit, effect, else let's play the default rock hit effect. So as long as we have only asteroids there, we don't need to add any groups because it will automatically fall back to this branch and the rocket effect would be played. Okay, let's modify the life cycle now because we need to send a signal. So let's create a new signal, bullet hit, and this signal would have two parameters, enemy and bullet. Okay, and we need again to connect the signal to the function, which is not created yet, but we'll do it briefly. Connect, what was the signal? Bullet hit, and callable root node, and the name of the function would be underscore on show hit effect. Very well. And last thing we have to do is to send the signal. So it will be done here in the process hit, because that's what happens when the area entered signal is detected. Hit points, okay, and if, yeah, and now each time the enemy is hit, we will send the signal bullet hit emit with parameters enemy area. Great. And of course the signal must be caught and processed. Again, it will be done in the main script. So let's copy the name of the desired function and create it. Func on show hit effect enemy bullet, and we need to call game manager, create hit effect with parameter self as the root node, enemy and bullet. Okay. Let's try it out. Yeah, can you see them? Can you see these sparks? Maybe not too visible, but when you play on a bigger screen, they are perfectly visible, and it looks pretty nice. Before we finish this part, let me show you two more tricks how to improve this audio part of the game a little bit. So first, we would like to play different sounds and rotate among them. This will be done by adding more sounds here. I already downloaded from the free sound site. Let's add Rock 2 and Rock 3 files here. Okay, and let's do the usual thing. Reimport, disabled, reimport. Okay, and we will create two more subnodes here. Rock 2 hit sound and Rock 3 hit sound. Okay, let's assign the sound files, this one and this one. Okay, where's the script? Where is the script? Sound manager here. Let's include these resources here. And now we have three different sounds, so we will create an array out of them. Let's start the array, and that. Oh, where did it go? Wait a minute. Ah, sorry. I just selected the wrong part. Okay, here it goes. And now, because this is an array, we cannot just call the function play on that. We need to pick a random member of the array, and there is a neat function. I think it was introduced in Godot 4. We create a random sound is from rock hit, sound pick random, and now we just play the sound instead of rocket sound. This is one thing, and the other one, it is also a good thing to change the sound pitch a bit, because it gives the sound effect something like a unique feel. So let me show you how we can do it easily. Sound pitch scale is, and select a random number from range, let's say 0.8 and 1.2. Let's try it now. Yeah, maybe it's not that obvious, but the sounds are a bit modified, and it definitely does not look like we are playing the same effect over and over. Okay, that should be enough for this video. Next time we will do a lot of interesting improvements to the player's ship.